all this. Anim bicep bulge anim blueprint. Let's set that back to our test guy. Now, if you may remember, we have a couple of blend shapes in him. We've got our left and right bicep bulge. So we'll do the same motion here. We'll go ahead and get the sub anim instance. And let's go ahead and set that to our base class, which is our test anim BP. And then we need to convert and convert back. So this skeletal control is going to be a bone-driven controller. Now this works great for simple things like bicep bulges. Actually, we need two of these because we got a left and a right one. Now we don't need to convert again. We're still converted. You only have to convert once. So you convert once, you put all your skeletal controls in there, and then you can convert back again. So you can chain them like that. So in our first one, the source bone will be the lower arm left. And for rotation, let's take a look at the skeleton. It's going to be the rotate Z. And for the other one, it's going to be the other arm. So for the destination, for the left one, we're going to set it to, for both of them we're going to set the morph target, but for the left one we're going to go morph target. Then I got to put in the name of the morph target. I don't know why it's switching back. Copy names. That's for the left one. Copy names. And that's going to be for the right one. Notice also you have material parameter too. So you can modify one bone based on another bone's movement. You can modify morph targets or material parameters, which is really cool. So like if you wanted to blend in, say, normal maps to get wrinkles in, and you had an eyebrow bone or something like that, that would be really cool. So here on both of these, I'm going to do remap source. And what that's going to do is that's going to change the relationship between the bone and what I'm driving. So the map range is going to be from 0 to 1. The source range, if I go to the skeleton, you'll see that we're already at 30. And if we rotate up, it's going to go up to like 120. So let's remap that to 30 to 120. So 30 is going to equal 0, and 120 will equal 1. And then let's look at the other side. And yeah, the same values are going to be there. So let's set the other one. So again, it's going to start at 30. So 30 on the joint is going to equal 0 on the morph target, and 120 on the joint is going to equal 1. And so what this will do, and it's a little hard to see, but this is actually driving the bicep bulges in the character mesh here. based on the rotation of his elbow. Now, to do more complicated things like the shoulder, I haven't found a really good way of doing that without adding custom nodes in the engine. So there is supposed to be a function called the pose driver, but I have not gotten that to work correctly, so I'm not going to show that to you. We created a custom node in the engine at my day job to basically take a joints rotation, take a target rotation, convert them to Euler rotations, and then subtract the two, and then we get the driven weight that way. But this is how you would do a really simple corrective blend shape like a bicep bulge. This also could work well with twisting. There's a separate node for twisting, but again, I've not gotten that to work well. And this works well. So if I got the joint twist value, I can use the same modify or the same bone-driven controller to accommodate that task as well. Now, when doing this, there's a handy little node for reading the joint values that is very helpful. If you come over here and branch off of this, under skeletal controls, there is observe bone. Now, this thing doesn't actually do anything. What I mean is that it doesn't modify a joint, it doesn't do anything that you'll see in the engine. All this is really going to do is tell you what the joint is doing while you're playing the animation here in the Anim Blueprint editor in Persona. So this is just a handy little utility. Sit there, go to bone space, and we will hit play. So right now it's not looking at anything, so let's go ahead and switch that to the preview instance. And now you can see the joints, translation, rotation, and scale as it's playing the animation. And you can convert the space. For example, if we set that the parent bone space and recompile, now you're seeing what its rotation is relative to its parent. And if you tick this, this is saying subtract the reference pose. In other words, this would be the equivalent of in Maya if you were using the joint orientate to zero out your joints. And so then we see there what he's got 30 degrees of rotation, or about 20 degrees of rotation, relative to its parent joint, relative to its reference pose. In other words, that's not the correct rotation, that is its rotation off of its A pose, off of this pose. So if you select that joint right here in the skeleton, you'll see that it's already rotated 30 degrees. So that's subtracting that 30 degrees off of that rotation. If you tick that off, it doesn't do that subtraction. And so now your rotation Z, for example, has jumped up to about 50. So again, this is just a useful debugging tool. This is not anything that will create any functionality in your rig, in your character. But when you're doing things like setting up this bone-driven controller, you need to know what the rotations are. This is a very helpful tool.